Large language models are made of these four major components, and now we are going to look at the details about the first one, that is the transformer architecture. So transformer architecture is the core of a large language model, and let me just do the full screen and what it contains. So this is a transformer architecture which many of you might have seen in the Attention is All You Need paper by Google. Talking about each individual component is out of the scope of this video, but in brief, what are the main components of this transformer architecture is the left side is the encoder part and the right side is the decoder part. So the encoder and decoder together contains the whole transformer architecture, and we are going to talk about this in the next few slides. So this is a simple way of talking about it. Just take as an encoder which takes a particular line, like here it is, I like dogs, and and then it is passed on to the decoders which translates it into the German language. And this is a very simple demonstration, not going into the too much technical terms that are there. This is the way it works. So encoders understands the language. It is more into for this understanding of what it means by telling I like a dog, and decoders are the ones that does the work, and it generates a text. Here it is the text that is there, and this is a very high level architecture, but end of the day it goes in little bit details. So the transformers has 6 encoders, as I was mentioning, and 6 decoders. Each of these contain the attention mechanism which allows the model to focus on different parts of the input text. So this means you feed the input here at the bottom, and the output from the first encoder is fed into the second encoder, and so on, third, fourth, it goes up all the way to the topmost encoder. Now by passing the data to these successive encoder layers, the model is able to capture deep and more complex understanding of the language semantics, and this is then fed to the decoder layers which are on the right side of the diagram. The encoder and the decoder can be used independently or together depending upon the task. For encoder and decoder model, it is majorly when they are working together, it is used to generate a task. Like in this case that I showed you, like if you want to convert in English to German, you are using an encoder-decoder model because you want to understand as well as you want to generate a summarization or a translation. Then there is encoder-only model. So encoder-only model is for good language understanding, right? When I say good language understanding, it is like sentiment analysis, sentence classification, whether you want to see whether a sentence is it a positive review, a negative review, or a neutral. So this happens by encoder-only model, and that gave birth to something called as a BERT. You might have heard about BERT. What is the full form? It is a bidirectional encoder representation from transformer. So it is an encoder-only model. That when people say BERT, that is the meaning of that. Then we have decoder-only model. Decoder-only model, as you can see, they are mainly also doing generation of tasks like text generation or whatever is that, it is able to do that. So the examples of the decoder-only model is ChatGPT, GPT-3, and all these things. So decoder models are good for generating tasks, and most of the research has been around the decoder models. Why so? Because decoder models are able to generate text. They are more useful as chatbots or virtual assistants, and that is why there is a lot of research in this space. And transformers are made up of layers of encoders and decoders, and depending upon the task we can use whichever type of model that we want. So this gave you a brief overview of both the components of encoder, decoder, and how to use it in our LLM application. See you in the next video.
And begin your journey toward AI-enabled excellence. Transform your AI strategy. Transform your leadership. Transform your future.